Hey, let's talk about arrays. So arrays are a really useful tool in computer programming, in part because we are often faced with this issue of trying to hold multiple things but not wanting to have multiple places to hold them. A really easy example is to think about holding a single name, a person's name, versus a list of names, like a roster in a class. Rather than have to keep track of 20 different names, it's nice to have maybe just one piece of paper with all the names written on it. So you kind of think of arrays that way. They're basically just a list. So let's contrast this with how a primitive type, for example, is stored in memory. Suppose I said int x equals 7. Essentially what's happening on the computer is I'm finding a little block of memory, I'm giving it the name x, and I'm putting 7 in that block. Now, what if I want to store a whole bunch of numbers, like 7, 12, 15, 82, and 3? Well, they can't fit in that block. So I do something a little bit different. I'm going to say int y. So kind of the same thing. I'm worried about integers, but I'm going to put open and close square brackets right in front of y. And this says I don't want n int, I want an array of ints. I want a whole list of them. Now, the big difference is going to happen is that when I make it, I need to specify how much room I need. So since arrays can hold more than one thing, the computer gets a little worried and says, wait a second, how many numbers are we talking about here? Do you want me to store 4 or do you want me to store 4 million? Because there's a big difference between the two. So the way we allocate space is by instantiating this array using the reserved word new. New says make space. Then we have to tell it what to make space for. We're making space for an int array, and we tell it how big it needs to be. Let's say 4. So now what happens are we actually have two different sections of memory are affected. This side of this line of code finds 4 blocks of memory in a row, 1, 2, 3, 4, and sets them aside to store integers. Over here, we still get that one single block that we give the name y, but instead of putting all of this inside the block, which we can't do, we instead create a reference, so an arrow that points to the beginning of that spot in memory. Now, this is kind of the difference between cash and a check. Cash is money. I can use it. I can spend it right away. Whereas a check is basically instructions for where the money is. It'll have a bank number, it'll have an amount, and it'll tell you that you can get it. So y is not the information. It's not these 4 numbers. Y is a reference to where those numbers are. So that's an important distinction. There's another video on references versus values that'll dig into that issue a little bit more. So now the question of what do I do with the information I want to put in there? How do I get these blocks filled? Well, I can't do this. I cannot say y equals 7. Because again, y is not a spot for an integer, it's a spot for a reference. So I can't put 7 in there. That's only for a reference, a memory location. I want to put 7 here. And maybe I want to put 19 there. And maybe I want to put 82 there. So what I need to specify is which block associated with y. So again, I'm going to use my square brackets, y square brackets, and then what I do is I put in an index number. So these 4 blocks can all be referred to by their position. This position is 0. That's the first position, second, and the third. So in a computer program, we always just start counting with 0. So that's the 0th block, the 0th index. So if I write y square bracket 0, saying the 0th block of the y array should be 7. Now 7 goes in that block. So this little piece of memory is just like this little piece of memory. They're both ints, they can both be used that way. It's just the way that I get to them, the way I get something out of them is a little bit different. So I can continue to fill this in. I might say y1 equals 19, y2 equals 82, and y3 equals 4. So I'm going to get 19, 82, and 4. And now I have a way to keep track of 4 numbers with only one reference y. So arrays are very helpful in that regard. And I'm going to have some follow-up videos that talk about different aspects of arrays that are really interesting, such as navigating arrays, which is similar to navigating letters in a string. We'll also talk about some of the differences between arrays and array lists, for example. Now, one very important thing to keep in mind when you're creating an array and going to use it in a program is that right here, when we said make this array large enough for 4 ints, we set its size and that's permanent. Arrays cannot get longer. I can't add to an array. So suppose I was using it to store these numbers and thought, geez, you know what? I really need to keep track of that one extra number. I'll have to build an entirely new array. So I can't just add on another block to the end of this. So hope that helped clarify arrays a little bit. Thanks for watching. Bye.